Okay, so now that we have the power rule for derivatives, we're now going to look at some other derivative rules. And in order to do that, we're going to take a look at what's called the differential operator, which is d by dx. So this is an operator on a function, looks like a fraction, and when it's in use, it often looks like a fraction too. But what it is it's something that actually takes the derivative of a function. Okay, so we had the derivative of x to the n was nx to the n minus 1. So x to the n went to nx to the n minus 1. So that's our first derivative rule. So d by dx is the same as what we had before for f primed. It's just going to make it a little bit easier to look at if we use d by dx. So d by dx of f of x is df by dx, is what we say, which is the same as f primed. F primed is the more convenient way of writing it, but we're going to look at this in a way that maybe this helps. Okay, so now we need to know what the derivative of a constant times a function is. Okay, so if we had, say, 7x to the 4, what's the derivative of that? Well, we're going to take a look at this and you're going to see that it's actually quite nice. Okay, so the first thing you want to do, df by dx is d by dx of c times g of x. Okay, so a constant times the function. And we use the limit rule. Okay, go right back to the first principles. And we'll use the limit rule for derivatives. We're plugging in x plus h into that function. And then x, so c times g of x plus h minus c times g of x all over h. So that's from first principles. Notice we can factor a c out of that. When you factor the c out, we have this. And one of our limit rules is that the limit of a constant times a function is the constant times the limit. You can distribute that in. Or the product of the limit of the constant times the limit of this. And a limit of a constant is just a constant. Okay? And this ends up being just the derivative. Okay? So f prime of x is c times g prime of x when the function f of x is c times a function. Okay, so an example of that. Well, let's take a look at this one here. So 3x to the fifth, well, the derivative of that, so f primed, is going to be 3 times the derivative of x to the fifth. Okay, because what's happening here, it's the constant, which is 3, times the derivative of the function. So this is like the c, and this is like the g of x. Okay, so you bring the power down, reduce it by 1 for that piece, and then you can just multiply those constants. Okay, so it makes it nice and simple. This one, same thing, bring the 8 down in front, but we can actually make it even easier. So you know you're going to have to multiply these constants together, so just do it as you bring it down. 8 times negative 7, negative 56. Reduce it by 1. Okay, so that is the constant rule. And then we're going to take a look at now the sum and difference rule. So the sum and difference, so f of x is g of x plus k of x. Okay, so we're going to take the derivative, d by dx of each one, so take the derivative of each side. Well, can we distribute that derivative in? Well, we're going to find out. Okay, so by doing the limit, okay, so g of x plus h plus or minus k of x plus h minus g of x plus or minus k of x. So remember, you're plugging in the x plus h into that function and then subtracting it when it's just the x. Okay, we can rearrange that. So we can bring the g of x over here, so minus g of x, put the g of x's together, and we can bring this over with the k of x, and we have the plus or minus in the middle. Okay, so that's not a problem. Now we can divide it up into 2, and two different fractions, okay, because we have the plus or minus here, we can make that into two fractions where h is the common denominator. If you don't see that, look at it backwards. What do you do when you have something like this? Well, you just add or subtract the numerators. Okay. And our rule for limits when we have a sum or a difference is we can distribute that in. So because you can distribute that in, we have now that the derivative of a sum or difference is the sum or difference of the derivatives. Let's take a look at an example of this one. Okay, so right here we've got x squared plus x to the fifth. So that would be g of x, and that's k of x. So it works out very nicely that the derivative is the sum of the derivatives of those two functions. So 2x plus 5x to the fourth. What about this one here? F of x equals 3 root x plus 4x minus 1. Well, that's the same as 3x to the 1/2 plus 4x minus 1. And now we can take the derivative of each one of those pieces. Okay, so the derivative is going to be 1/2 times 3/2. I don't know why that's negative. Okay, so that should be a positive. Okay, and that's a positive there. And then the derivative of 4x is just 4, and the derivative of 1 is 0. So that becomes 3, and we've reduced that by 1 over 2 root x plus 4. Okay, and something like this up here. We've got 3x to the fourth minus 2 over x. We can take the derivative of those separately. Okay, so that's the same as that. 2 over x is 2 times x to the negative 1. So the derivative, 4 times 3 is 12, x to the power 3. Bring the negative 1 down, that becomes a positive 2. X to the negative 2, and simplify that to its original form, and you've got this. Okay, so that's that one. Now we can take a look at the next rule, which is an important rule called the product rule. Okay, so the product rule, this is going to help us out a lot. The derivative of a product of two functions. Well, we'd hope that this is going to be the product of these two derivatives. I'm going to tell you right now it's not going to be. Okay, so we have to play around with this a little bit. So the derivative of f of x is the derivative of g of x times k of x. We're going to plug in the x plus h into this, and then the x, and do the first principles. Okay, so limit as h approaches 0 of this. Okay, it's not as easy to see. You can't really break that apart and bring it back together. So there's a little trick that we play here. We're going to add and subtract something in the middle that is not obvious. Okay, so if we add and subtract this piece here, then we can get a common factor out of a couple of them and play around with it a little bit. Okay, so here we go. We're going to take these first two here and factor out the k of x plus h. And then in the second part here, we're going to factor out g of x. Okay. Then we've got a common, well, we don't have common, we have two fractions here. Okay, so we can break that up into two fractions. And now we have something nice here. Okay, so we've got this piece over h times k of x plus h. And we can distribute the limit in. Okay. And we can distribute the limit in again to a product, right? So the limit in the product. This is the derivative of g of x. This is just going to be k of x as h goes to 0. This stays the same. And this is the derivative of k of x. And here is our rule now for the product of two functions. Okay, so as We're looking at the product of g of x times k of x is going to be the derivative of the first times the second one without the derivative plus the first times the derivative of the second one. Okay, so an example of this, well, we can write it nicely like this too. So the derivative of the first times the second without a derivative plus the first times, or plus the first times the derivative of the second with the derivative there. Okay, so let's take a look at this. We could multiply this out and just use the power rule and sum rule, but it's going to get more complicated, so we might as well try it now. So if we want to take the derivative of this piece here first, okay, so that's g of x, take the derivative of that, which is going to be 4x plus 3. Then just write the second piece in, plus the first piece without the derivative times the derivative of the second one, 1 minus that. So that's that rule. And then you simplify it to its original form. Okay, so that's the constant rule, sum and difference rule, and the product rule.